Okay, so next we are going to use numerical values of some functions to calculate their derivatives at some point. The functions themselves are not given. Simply it's given that u and v are functions of x and they are differentiable at x equal to 0. Also, these values are given. The values of u and v at 0 are given, 5 and minus 1 respectively, and the values of the derivatives of u and v are also given at 0 and they are respectively minus 3 and 2. With this much information, we have to find these derivatives. The derivative of the product uv, the derivative of the quotient u divided by v, that of v divided by u, and 7v minus 2u at the point x equal to 0. So this means, unlike the other problems that we already have solved, where say you have a product of two polynomials, if you wish you can do the multiplication first and then you can use your sum rule, power rule, those things to find the derivative. Here, however, you have to use the product rule because you don't really know what these functions are. So that's the only option here. Just like that, in these two parts, you have to use the quotient rule. Okay, so let's see the solution. A. We have, and keep in mind that we have to find the derivative at x equal to 0. If you are using this notation to denote that you are writing the derivative at x equal to 0, you write like this. Put a vertical bar here and below that, to the right of it, write x equal to 0. And this bar will continue until you substitute x equal to 0. Okay, so now we are just simply going to use the product rule. By the product rule we have u times v prime. Although this is the notation that we are using here, but the prime notation has been used to give the values of the derivatives. So let's just use the prime notation. In prime notation, it's very easy to write also. U v prime, that is u times the derivative of v plus v times the derivative of u. Oh, okay. I need these values. So this is nothing but u of 0 times v prime of 0 plus v of 0 times u prime of 0. Now that you have made the substitution, there is no need to write it anymore, this part. Now u of 0 is 5 times v prime of 0 is 2 plus v of 0 is minus 1 times u prime of 0 is minus 3. So that means 10 plus 3. So this is 30. Next, B. We will have to keep this part. Okay, we cannot erase it right now. So in B we have the derivative of u divided by v. And we need it at x equal to 0. Let's continue from here. So by the quotient rule, what will it be? First you recall the quotient rule, you square the denominator. V square really means V of x whole square. We are not writing the independent variable here. We are simply writing V square. If you want, you can write V of x whole square. Then in the numerator you write V and then multiply it by the derivative of u, that is Vu prime, minus, in the quotient rule as opposed to the product rule, in place of plus you have minus. Then the opposite. Opposite means now you keep u and differentiate v. So this means v of 0, u prime of 0 minus u of 0 v prime of 0 divided by v of 0 square. Okay. So this, now if we substitute the values, what is v of 0? Minus 1. Minus 1 times u prime of 0 is minus 3 minus u of 0 is 5 times v prime of 0 is 2 divided by v of 0 whole square. So this is minus 1. So the denominator anyway is going to just simply vanish. So this means 3 minus 10. So minus 7. Next, part C. In part C we have v divided by u. So here you just interchange u and v, that's all. Here in place of v you write u becomes v becomes u, and here also v becomes u. So that means u of 0 v prime of 0 minus v of 0 u prime of 0 divided by u of 0 square. Okay. Now u of 0 was what? 5. Here we have to change everything. U of 0 is 5, v prime of 0 is 2 minus v of 0 is minus 1 and u prime of 0 is minus 3 divided by u of 0 square, that is 5 square. Okay, so 10 minus 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 means minus 3 divided by 25. So this is 7 divided by 25. And then D. D is simply going to need the difference rule and the constant multiple rule, that's all. So here we have d dx of 7v minus 2u at x equal to 0. So this is just 7 times v prime minus 2 times u prime at x equal to 0. Minus 2 times u prime of 0. v prime of 0 is 2. So 7 times 2 minus 2 times u prime of 0 is minus 3. So we are getting 14 plus 6, that is 20. So these are the values. Now for the 40th one, it's similar. Okay, if you see the next exercise, in the next exercise exactly similar, only the point is no longer 0. The point where you have to find the derivatives of these quantities is 1 in place of 0, and the given values are also something different. We still have two functions u and v which are differentiable functions of x, but now they are differentiable at 1, and these values are given. U of 1 is given to be 2, then u prime of 1 is 0, then v of 1 is 5, and v prime of 1 is minus 1. With this information, you then have to find the derivatives, these following derivatives at x equal to 1. And the derivatives are exactly the same. Product, the two quotients, and again 7v minus 2u. So you can similarly do this one also. So that I leave to you. The 40th one I am leaving to you. So let us next see 41. Yeah. Forty-one is geometric. A curve will be given. We are asked to find tangents and line perpendicular to tangents, those things. It has 3 parts. Let's see what part A is. Find an equation for the line. Perpendicular to the tangent to the curve. Y equal to x cube minus 4x plus 1. At the point 2, 1. Now we will see the other parts also, but let us first solve this itself, here itself. A. So what we are given is that we are given this curve. So this curve will have some tangent at this point. You can put x equal to 2 here. What will you get? 8 minus 8 plus 1 is 1. So yes, this is indeed a point on this curve. At this point, this curve will have some tangent. We do not have to find the tangent's equation, but we will have to find the equation of that line which is perpendicular to the tangent and also passes through this point. So what we can do, of course, First of all, let's differentiate this y with respect to x, and that will give us the slope of the tangent at the point x comma y, and then we will find the slope at this point, and then we will figure out the slope of the line perpendicular to this tangent. You know how to find, if you are given the slope of a line, you know how to find the slope of another line which is perpendicular to this line. So let's find the slope first. The given curve is minus 4x plus 1. Just give me a moment, okay. Now we differentiate this. So by using the rules, the power rules, constant multiple rule, everything, what are we going to get? X cube will give us 3x square, and minus 4x will give us minus 4, and plus 1 of course will give us just 0. So this is the slope of the tangent to this curve at the point x comma y. So the slope of the tangent to y equal to x cube minus 4x plus 1 at the point 2 comma 1 is, so although you are also given the y coordinate, but you only need the x coordinate because in this expression there is no y. So you just put x equal to 2 and calculate this. So what will it be? 4 times 3, 12 minus 4 is 8. So the slope of the tangent is 8, and that's why the slope of any line perpendicular to the tangent will be the negative reciprocal of this slope. Hence, the slope of any line perpendicular to the above tangent is this. The equation of such a line that also passes through that point. I mean, if you have a tangent, there may be many lines, means there are infinitely many lines, all of which are perpendicular to that tangent. But we need the one which also passes through the point 2 comma 1. So you can now write the equation. You know the point through which the line has to pass. You also know its slope, so you can write the point slope form of the equation, which is just this. Line passing through 2 comma 1 is y minus the y coordinate equal to the slope times x minus the x coordinate. So I am just going to leave it like this. You can do the simplification, whatever you want to do with this equation, however you want to write it, represent it ultimately. We instead go to part B. What is the smallest slope on the curve? On the curve means on this curve. At what point on the curve does it have this slope? Have this slope. Okay, so we already know the slope, which is our dy dx, which is 4x square, 3x square minus 4. The slope at x comma y is 3x square minus 4. Now the smallest this expression can be is when this is equal to minus 4. You know why? Note that three x square is non-negative. Why? Because no matter what the real number x is, 3x square is always non-negative. It is positive precisely when x is positive, but if x is 0, then this is equal to 0. Oh, and also when x is negative, I messed that up. This is positive precisely when x is not equal to 0, not just positive. And this is equal to 0 when x is equal to 0. In any case, it is non-negative, it is not negative. So, this is greater than or equal to minus 4. This slope is always greater than or equal to minus 4 and becomes minus 4 precisely when x is equal to 0. That's the only possibility. Thus, the smallest value of is minus 4 and is attained at x equal to 0. And what's the y coordinate when x is equal to 0? When x is equal to 0, y equal to what was the original curve? X cube minus 4x plus 1. 0 cube minus 4 times 0 plus 1. This is equal to 1. So the point at which the smallest slope is attained is 0, 1 on the curve. So we have to find the smallest slope as well as the point where it is attained. So we have found these things. You can complete this part B by writing thus the smallest slope is attained at the point zero comma 1. And then there is a part C also. Find equations for the tangent. To the curve where the slope of the curve is 8. Well, equations, because potentially this slope may be attained at more than 1 point, that's possible. And at those points we have to find the tangent equations. So now our slope value should be 8. We have dy dx equal to 8 if and only if 3x square minus 4 equal to 8. So adding 4 to both sides we get 12. Dividing both sides by 3 we get 4. So you see we do have two positions, two values of x for which this thing happens. So correspondingly there will be two values of y as well. When x is, let's take the negative first, minus 2, y is x cube, that means minus 2 cube, minus 4x, minus 4 times minus 2, plus 1. So this is minus 8 plus 8 plus 1. So this is equal to 1. And when x is equal to 2, then also I think y is 1. Let's see. 2 cube minus 4 times 2 plus 1. Yes. So here also y is 1. Thus, the slope of 8 is attained at the points minus 2 comma 1 and 2 comma 1 on the curve. And now we have to find the tangent equations. The equation of the tangent to the curve, I mean ideally you have to write, but it's understood, I am not writing that, of the tangent at minus 2 comma 1 is, so we have the point and slope of course has to be 8, y minus 1 equal to 8 times x minus minus 2, so x plus 2, and the equation of the tangent at 2 comma 1 is that other one, similar one. This time we have y minus 1 equal to 8 times x minus 2. So these are the two tangents. The next one is also similar. Let's see what the problem is. It also has two parts. In part A, find equations for horizontal tangents. To the curve y equal to, again a cubic equation, x cube minus 3x minus 2 this time. Also find equations for the lines that are perpendicular to these tangents. At the points of tangency. So for horizontal tangents, the slope of course should be 0. So what you have to do, you have to first of all differentiate of course. dy dx here will be 3x square minus 3. So that's the slope. You set that equal to 0 and find the x values. Those will be the points where you will have horizontal tangents. I mean of course corresponding to those x values you have to find the y values as well, and the xy pairs will be the points where you will have horizontal tangents. So then you find the equations of those tangents. You know the points now, and slope will be 0 because horizontal tangent. And then you have to also find the vertical lines through those points, I mean perpendicular lines, because the tangents are horizontal, the perpendicular lines will be vertical. The equations of the perpendicular lines to these tangents at the points of tangency. So this one is also similar. So I am leaving this to you. And let's see what part B has. What is the smallest slope on the curve? You can clearly see what the smallest slope will be. The slope is at any point 3x square minus 3. So just like the previous one, the smallest slope in this case will be minus 3 and it will be attained at x equal to 0. Same, exactly similar situation. At what point on the curve is this slope attained? Does the curve have this slope? Also, find an equation for the line. That is perpendicular to the curve's tangent. At this point. Oh, this is not a question, this is an assertion. So obviously you now know that the smallest possible slope is minus 3. You find the point where this is attained. X value will be 0 and y value, you can immediately see what the y value is, minus 2. So at 0 comma minus 2, this smallest slope of minus 3 is attained on this curve. And at this point 0 comma minus 2, you have to actually find an equation for the line that is perpendicular to the tangent there. So tangent slope is minus 3. So the line perpendicular to the tangent will have slope 1 divided by 3, negative reciprocal of minus 3. So you have the point, you have the slope, so write the equation, that's it. So you do this problem. And if you find any difficulty, write in the comment section below. And let's just stop the video here itself for tonight. Tomorrow also we have our usual upload and we will continue with more problems on linear algebra that we have been doing. Okay, so see you tomorrow with that. Until then, this is me, Lucifer from A Mathematical Room. Have a nice night.